Hello, I hope you are having a wonderful day. Today we're going to talk about solving radical equations. We have worked for a while on simplifying radicals, operations with radicals. We can add them, multiply, divide, all the things. We can do it all. But now we're actually going to use all of that we've learned to solve equations. So if you want to pause here and write down the steps, you can, but we're going to walk through them with each problem. So you're going to get to know them really well. We're just going to start with number 1 as an example. I think I've picked out 5 problems if I remember correctly, and each of them is a little bit different. So I do think it's important to kind of look at all these, but if you feel confident, you're welcome to go ahead and do these on your own and come back to the video to check your work and make sure that you're doing them correctly, or if you get stuck on a problem, you can come back to the video and see how to do it. All right, so let's just dive right in. The instructions or the steps tell us to isolate the radical on one side of the equation. So the radical is only what is under the radical symbol. Everything else has got to go. All right, so it's all got to be moved to the other side. So we want to subtract 5 from both sides. And that's going to leave us with the square root of x equals, because these will cancel, 7. So we have isolated. Now we want to raise each side of the equation to the power of the index to eliminate the radical sign. So remember that the index is the little tiny number right here. And when it's not there, it's understood to be a 2. So we are going to square both sides of the equation. And just like whenever we had addition and we undid it with subtraction, those are called inverse operations. They undo each other. The square root and squaring something are also inverse operations and also undo each other or cancel each other out in some way. So when you take the square root of x and square it, you just get x. The radical goes away and the exponent goes away. And then 7 squared is equal to 49. So we got x equals 49. So we raised the power, we solved the equation, but we have to check for extraneous solutions. And extraneous solutions are solutions that you found algebraically, so you found by doing the math, but they don't actually work. It's like a false positive. You know, you get an answer, but actually it's not really an answer. It's not going to work. So we always have to check for extraneous solutions. So we are going to come over here and we're going to check the square root of 49, because that's what we found x to be, plus 5 equals 12. The square root of 49 is 7, plus 5 equals 12. That is true. So we can confidently say x equals 49 is the answer to this problem. All right, so let's jump to number 3. If you want to pause and do number 2 first, you can, whatever makes you happy. Okay, so we're going to isolate the radical. Once again, this is only what's under the radical, and it includes all of what's under the radical. So over here, we are adding 10. So that means we have to subtract 10 from both sides to undo that. And that's going to leave us, these are going to cancel because 10 minus 10 is 0. So it'll leave us with the square root of a plus 7 is equal to 11 minus 10, which is 1. So now we've isolated. We're going to raise each side to the power of the index. So we're going to square both sides. That's a beautiful 2. All right, and remember that when we square a square root, it just cancels the radical and the exponent. So we're going to get a plus 7 equals 1 squared, which is 1. And now we're going to solve the remaining equation. So we'll subtract 7 from both sides to get a equals negative 6. And then we have to check our answer. And we do that using the original equation. So 10 plus the square root, we got a equals negative 6. So that's what we put here. of negative 6 plus 7 equals 11. So 10 plus the square root of 1 equals 11. The square root of 1 is 1, and 10 plus 1 does equal 11. So we can confidently say that A is equal to negative 6. All right, so number 5 takes us back to some rational exponents. So the first thing that I think you should do is actually write this as a radical. So we're going to rewrite it. Negative 36 equals negative 9, and remember that to the 1/2 power means the square root of c minus 12. So now we can isolate the radical. So here we are multiplying by negative 9, so we need to divide by negative 9. And negative 9 divided by negative 9 is 1, so that cancels. And negative 36 divided by negative 9 is positive 4. So 4 equals the square root of c minus 12. So then we get to square both sides. So we have 16 equals c minus 12. We add 12 to both sides, and we're going to get that c equals 28. And then we have to check our answer. So negative 36 equals negative 9 times 28 minus 12 to the 1/2 power. So we get negative 36 equals negative 9 times 28 minus 12 is 16 to the 1/2 power. And remember that the 1/2 power means the square root. So this is negative 9 times 4, and we don't even have to rewrite that. Negative 9 times 4 does equal negative 36. So c equals 28 is, in fact, a solution to this problem. All right, number 7 is to the 4th power. I wanted to do one of those with you really quickly. So let's isolate. We're going to add 9 to both sides to get the radical by itself. So that gives us the 4th root of 8k plus 12 equals negative 2. Because negative 11 plus 9 is negative 2. All right, so then we're going to raise both sides to the 4th power. And remember, that's just going to cancel everything over here. So we get 8k plus 12 equals negative 2 to the 4th power is positive 32. No, it's positive 16. I apologize. Okay, so then we're going to solve for k. 8k equals 4. Then we're going to divide both sides by 8. And we get k equals 1/2. Then we're going to check our answer. Oh, that's beautiful. All right. The 4th root of 8 times 1/2 plus 12 minus 9 equals negative 11. So the 4th root of 4 plus 12 minus 9 equals negative 11. The 4th root of 16 minus 9 equals negative 11. The 4th root of 16 is positive 2 minus 9 equals negative 11. And this is not true because this is negative 7. So negative 7 does not equal negative 11. So in fact, this is not a solution. There is no solution. And this is called an extraneous solution. In some problems, you're going to see this, like number 9, where you have a radical equals a radical. And in this case, as long as they have the same power, you can square both sides. So we are going to square both sides, and it's going to get rid of both radicals. And we're going to have u minus 8 equals 43 minus 2u. And then we're going to solve our equation for u. So add 8 3u equals 51. And then divide both sides by 3 to get u equals, let me remember, 17. And then we're going to check our answer. So let's erase this so I can actually see. So if u equals 17, then we are going to have the square root of 17 minus 8 equals the square root of 43 minus 2 times 17. So the square root of 9 equals the square root of 43 minus 34. So this is going to be 3 equals the square root of 9, which is true. And that means that u equals 17 is the answer. All right, I've got number 11, and then I've got one more for you, and then I'm going to let you go. All right, so in this one, I thought it was important to show you a problem where you can't get rid of all of the coefficients. So if you look here, we can divide both sides by 4, and that's going to give us 3q plus 15, or the square root, sorry, equals 3 square root of q, but we still have this 3 left. Well, as long as it is multiplication, we are going to be able to go ahead and square both sides, and I'm going to show you what that does. So on the left side, we're just going to get what's under the radical like usual. But on the right side, we also have to square this 3, because when you square something, you get 3 square root of q times 3 square root of q. So you have to multiply the 3's to get 9 and multiply the square roots of q to get q. And so when you square things that are multiplied together, you kind of do distribute the exponent. But I don't love saying that, because then a lot of times you get confused about what you're allowed to do and not allowed to do. And I don't want you to think that you could distribute here, because you cannot do that. All right, so on the right side, we're going to get 9q. All right, so if we subtract 3q from both sides, we're going to get 15 equals 6q. And then we'll divide both sides by 6 to get q equals 5/2, or 2.5, whichever you prefer. And then we're going to check our answers. So we have 4 times the square root of 3 times 5/2 plus 15 equals 12 times the square root of 5/2. So I'm going to leave the square root of 5/2 in here because I don't want to deal with it. And I'm going to just work on this. So we're going to have 4 square root of 15/2 plus 15. And that simplified to 4 times the square root of 45/2. And then whenever you do 45/2, you can split this into 4 times the square root of 9 times the square root of 5/2. Because 9 times 5 is 45. All right, so then we get 4 times 3 times the square root of 5/2, and we still have equal to 12 square root of 5/2. And 4 times 3 equals 12, so this is correct, and we find out that q does equal 5/2. And finally, the last problem that we're going to work together, but this one was important because you're going to have to square a binomial, and I just want to make sure you don't forget the proper way to do that. So the radical is already isolated, so we are going to start by squaring both sides. So on the left side, we get 6m minus 38. Wow. On the right side, when you square a whole binomial, that means you have to write it twice and multiply them, okay? So this is where we use the FOIL method. So we have 6m minus 38 equals m squared minus 5m minus 5m plus 25. And then we're going to combine like terms. 6m minus 38 equals m squared minus 10m plus 25. And now that we have a squared in here, we have an exponent. This is actually going to be a quadratic function that we have to solve for. So I'm going to move everything to the right side just because that looks easier. We're going to get 6m equals m squared minus 10m plus 25 plus 38 is 63. Then we're going to subtract this 6m so that we can get it equal to 0. So we have 0 equals m squared minus 16m plus 63. And then whenever we want to solve a quadratic equation that's set equal to 0, we factor it and then set each factor equal to 0. So we have m. We want things that multiply to get 63 and add to get negative 16. So that's going to be negative 9 and negative 7. So then we set each of those equal to 0. So we have m minus 9 equals 0 and m minus 7 equals 0. So we're going to find that m can equal 9 and m can also equal 7. So we actually have to check both of those answers. So we're going to bring this over and check each answer. The square root of 6 times 9 minus 38 equals 9 minus 5. So we're going to get 54 minus 38 under here equals 4. And 54 minus 38 is 16. And the square root of 16 is in fact 4. So m equals 9 is a possible solution. And then we're going to plug in 7. So we get the square root of 6 times 7 minus 38 equals 7 minus 5. So 6 times 7 is 42 minus 38 is going to equal 2. And this gives the square root of 4 equals 2, which is true. So m equals 7 is also an answer. So both answers work. And that is all I have for you. So thank you for watching, and I hope you have a great day.